Hi, I'd like to take some time to explain or provide you some guide with some of the problems I gave you as a assignment number 4. Okay, so I won't provide the solutions, but you will certainly find that these will help you start to engage much faster without spending too much time in trying to figure out what this is all about. Okay, number 1 is asking the likelihood of obtaining a certain sample. Okay, that was the key to our this week's lecture. So you may find that these lecture notes are very useful, but I'd just like to tell you here, the first question is, it's always a good idea to do a sketch, when you solve a distribution related questions, because it's easier and intuitive. And mu is here as 20, and sigma is something you cannot observe unless you're comparing with another distributions, and your sample size is 36. Okay, so the question is, do you need to use a sampling distribution, or do you need to use a just regular distribution for populations? So because we are determining the probability of obtaining sample average of this level, we need to use sampling distributions. So if you go back to my slides, here are the definition of sampling distributions, and their distributional properties. You might find it useful. So to calculate this question, you need to have the sampling distribution instead of the original population distribution. So to rescale it, okay, assuming this is a sampling distribution, this will have mu of 20, right, based on this property, mu of 20, and you will have standard error of this size. So you need to figure out what is the standard error. Okay, it's going to be square root n sigma. So this, you have information to determine what is the likelihood of obtaining sample size of this small. Okay, so you get the area for this part, and that's going to be the answer for this particular question. So you probably won't, it's not probably, you need to use Excel. Okay, so if you're still thinking of going back to the original 2060 and convert it to z value and then look up the z table, that means you didn't listen to my lecture. Okay, that means you're still staying 1 or 2 years behind than your peers from this class. So you're using, sorry, it's very thick. Okay, it's going to be norm dist. Okay, so I also provided you with detailed information here in terms of how to utilize the Excel formula. Okay, so you may find that, isn't it the formula to calculate the population distribution? No, this applies to all the normal distribution. So you will need to use that. Okay, you just need to figure out what are the 4 items that goes into the Excel formula. Number 2 is a little tricky because it does not provide the actual population proportion. It only provides you with a hypothesized population average and the standard deviation. Okay, so we'll talk a little bit more next class, because that is immediately related to the hypothesis testing. Okay, so anyway, long story short, to calculate question number 2, all you need to do is to consider the claimed or hypothesized mean and standard deviation and determine the likelihood of obtaining this. That will be all you need to do. Okay, but I think you need to think why this question can help us either debunk or support original claim based on the likelihood of the sample. Okay, that's hard part, but try your best. If you can make sense of that, just solve it as a problem. Okay, so question number 3, we did this during the class, so I'm not going to go through the Excel part. I think Excel part, one thing you need to be careful is if you're using Mac, this Excel applet is not going to work on your Mac. So you need to do is you need to go to the VLab and connect to the virtual computer the school provided to your account, and you run the Excel from there. Or you can borrow your friend's laptop and run it from there. So when you open the file, you will see that this enable the macro. You need to enable this. Okay, otherwise it won't run. Okay. In addition to that, you need to make sure whether you have these available. So click Option, go to Add In. Okay, and then as you can see, that I have Analysis 2-pack made available. But click Go. I have more need to made available here. Pick Analysis 2-pack VBA. So both 2-pack and 2-pack VBA needs to be enabled to run this app successfully. So with that, you're ready to roll. So if you look at your problem description, it has 6 large blocks. 1, 2, 3, 6 large blocks. So first block, I already filled it for you. So this is expected properties. So that means that when I generate the data, this is the distribution characteristics I used to generate this column of data. Okay, but whether actually it followed this particular distribution, that you need to calculate. Okay, how do you calculate? You basically need to use Excel formula here. So to learn how to make this shape in Excel, you need to make a histogram. So you just click A column and then go to Insert and go to Recommended Chart, and I think you will need to use this. This is nothing but histogram. Okay, you need to use this histogram, and you click OK, and you can visually confirm the shape. So as long as it is roughly resemble the normal distribution, you can consider that as a normal. Okay, and then to calculate the average, you need to calculate average. Average for column A, column A to A. Okay, close parenthesis. This is your average for everything in column A. And for the standard deviation, it is STDEV.S. Okay, or you can use P in this case because we're considering that as a population. A to A. Okay, this will give you the standard deviation for the population. So this will help you take care the this block right here. For this block, okay, and this block, you need to calculate based on the formula. Okay, remember that this part is expected properties. So when your population has a mean of 500, standard deviation 50, when you are using the sample size 25, and what is the what's the mean and standard deviation of your sample average is going to be. Okay, so that is the question. So the theory tells us, right? Theory tells us what? Where do you go check the theory? So theory basically is our models and formulas. So where is it? Here, this is the formula or theory in my language that can help you predict, right, what these two contents going to be. Okay, so you may be asking, what is the role of K there? That's a very good question. K doesn't really play anything in terms of determining the mean and standard deviation. Okay, it's just help us generate enough observations so that we can summarize and confirm what we are thinking in this and this area. Okay, so to make sense of this part, you need to actually run this simulation. Remember, your sample size is 25. Okay, your sample size is 25, and you are randomly drawing 200 samples here. 200 samples, each with a sample size of 25. And you do click it. Okay, I didn't enable it. I need to enable it. It will start to run. If you have a slow computer, you need to be patient, okay, because it's going to take some time to run and get finished. So as you can see that it's horizontally, this is one sample, okay, and vertically, it's 200 different samples, okay, and then you need to calculate the sample averages row-wise, okay, row-wise. So let me just wait for a second to see if when it can finish. Okay, it looks like it's done, and as you can see that the row-wise, you are seeing sample, the first sample, second sample, third sample, and so forth. Okay, so I'm not adding a index number for each samples. The column-wise, right? Column-wise, this is the first observation from the first sample, second observation from first sample, all the way until 25th observation from the first sample, and so forth. So what you need to calculate here is mean. Okay, so average for everything in this row except column A. Okay, so you're getting average of the first sample. So that's sample average. Okay, the good thing is you have 200 of these. So some of you asked me, how did you do the quick filling the thing, right? If you highlight the first one, highlight the first calculation in the series, you see this green dot here. If you double click it, it will fill rest automatically. Okay, and then we can do the calculation. We can do the calculation for average for all the sample means in column AA, and we can also calculate standard deviation of the column AA here. So that will be something I'll expect from you here in the this and this matrix, right? Just figure out what's the mean, what is standard deviation of the averages, and that's something you need to do. And in terms of shape, do the same thing. Plot a histogram to see what is the shape look like for this 200 observations. You will have information for this block and this block. Okay. And last question is actually something I show you at the beginning of our stats section of the class. So the very first example I showed you, the temperature and hardness example. Okay, so my intention is to let you replicate the exactly same problem. So you will be able to produce graph like this, and then you'll be able to calculate, I think, the second estimation result. Okay, but to do that, you need to do a little bit of prep. Okay, so this problem requires to use multiple tools in Excel. Okay, so as you can see from the description, I gave you a instruction to come up with a data which you will be needed for this problem. So you basically need to create 4 different columns. The first column is purely random. Okay, this column is purely random, and second column is also random, but they have different way of being generated. So for the first column, okay, this is my formula. Okay, this is my formula. Rand imp rand 2512. So what this does is it will generate a random number that has average of 25, standard deviation of 12. Okay, so the first component, first argument in the function, this will create a probability, and your random number will generate a random number based on the probability that follows the distribution average 25 and standard deviation 12 and so forth. And with that, you need to create 250 here. And second one is also a random number, but this one you need to generate a little bit differently. You need to go to data, okay, and then data analysis here, and you will see a random number generation tool. Okay, you go here, you're creating one column, you're creating 250 random number that will follow normal distribution with mean of what? With a mean of 120, sigma of 35. Okay, 120 here, sigma of 35. And I think for random seed, you can specify 65. So this random seed will help to ensure exactly same set of random number so that you can compare what you have done, okay? Otherwise, it will keep generating random number differently each time you run this module. But if you set the same random seed, you will get exactly the same set of a random number each time you do that. You output it to the column B, and you will be you'll have the second column, and the third column C is actually a calculated column. You just have to square the column B, and that's what you need. And the last column, hardness, is actually you need to follow the formula I gave you. The randomizer column plus 2 times temperature column, right? And then minus 0.006 multiplied by temperature square column. Okay, so you have seen that this is actually the model, right? This is actually the model that created hardness value. So this is a data generation process for the hardness variable. Okay, this is information only God would know. Okay, but since we are generating this data, we know this information in advance. So the whole idea is we will see whether this formula, okay, this formula we're using here can actually be the result of our estimation. Okay, and with that, I think the second requirement here asks you to generate the scatter plot. To generate the scatter plot, you need to pick column B and column D, column B and column D as instructed, and then go to Insert and go to Recommended Chart. So here, the first choice is the scatter plot. Okay, see if that is similar to what we have done here, right? You won't see exactly the same, but you'll see the same pattern will appear here. Okay, and then the next thing we're going to do is follow the instruction written here, which is the one very important module that we're going to be repeatedly using in this class, is a regression tool. Okay, regression tool basically will help you estimate the coefficient. Okay, here is a regression. You go here. Y. So I think I'm asking you to run two different things here. In the first thing, you need to specify y, okay, y, which is going to be from D1 to D251, I believe, since we have 250 observations. And for x, at the first time, for first model, it's going to be B1 all the way to B251. We have label, and we're going to output the outcome somewhere. Okay, you're going to output the outcome somewhere, and then you do that, you'll get the result. And you need to run it one more time. Yes, you need to run it for one more time to run the second model here. And then you will get a result, something like this. I can show you. You can get a result, something like this. So obviously this is the, obviously this is the thing, right? This is the thing you will need. This is the thing. Well, this is the thing that you'll be seeing graphically, visually, but you will get a result something like this. Okay, like this. So you will be judging the quality of the fit based on the this score here, score. So you will see which one, right? Whether the number 3 or number 4 will give you better fit, and compare this result, okay, compare this result with the way you have generated your data, and then the way your constant and those coefficients, whether your estimates agrees with what you have done. I think that's what matters. So the number one goal of doing this exercise is to see whether your estimation methods are really that powerful, so they can tell us something about the original data generation process, right? And number 2 is I want you to get familiar with the regression tool, which I'm going to be using a little bit more over the next couple of lectures. Okay, so yeah, that'll basically be it for your homework this weekend. Okay, thank you.